This is flow graphs example number 1. Draw the direct form 1 flow graph of a system function h of z. In this problem, we are looking for the direct form 1 version of the flow graph implementation of this particular system function. I'll note right away that the leading coefficient in the denominator is not equal to 1. That means we need to spend a little bit of effort putting the denominator into a standard form. I'll begin by doing an operation to get the denominator to have this leading coefficient set equal to 1. So I'll extract the value 2. That means I need to divide all the remaining coefficients by that value of 2. And then I'll divide through each of the numerator coefficients by this value of 2. Next, to make sure that I get the denominator coefficients set properly, to continue placing the denominator into standard form, I will begin by just doing a copy of the numerator. And then we want to have 1 minus the sum of all the remaining values. So I'm essentially taking the negative sign and pulling that out of each of the coefficients. Now that I have it in this standard form, I'm ready to translate directly into the direct form 1 flow graph. I have my input x of n. I have my first delay element z inverse and another delay element z inverse. And x of n passes into this structure, and then the standard layout is the b coefficients, that would be the numerator coefficients, starting with b0. And b0 is right here. That would be the 4, the 5, and the minus 6. I can then directly translate those onto my flow graph. That takes care of the so-called forward coefficients. Then I continue by putting down the reverse coefficients. I need another pair of delay elements, and then the a coefficients feed back and then sum together right here. Since I've made the standard form modifications, I can simply put down the a1 and the a2 coefficients, and that would give me the positive 2, which is equal to a1, and then minus 3 would be equal to a2. I can then translate those directly onto the flow graph. And that's the final result. Now I will point out that with some practice, you can directly translate the coefficients that you see here. So we start with 4, 5, and the minus 6. That would take care of the numerator coefficients. And then in the denominator, as long as we have that lead coefficient set equal to 1, then I can translate the negative 2 onto the flow graph as long as I remember to change the sign. And the same thing for the 3. All right, that takes care of this problem.